Welcome back my dear friends, a very good morning, good afternoon, good evening to all of you, and this is the second class in DADM 2, which is data analysis and decision making 2, and the course has just started. We have completed one lecture, this is the second one, and as you know, this is a 12-week course for 30 hours. Each week we will basically have 5 lectures, each lecture being for half an hour, and after each week we will basically have one assignment each. So, as you know, and by the way, I am Raghunandan Sengupta from the IME department, IIT Kanpur. Now, as you are aware, we are discussing about utility analysis in a very simple way, and as you can understand that when we are trying to rank any decision depending on what the overall utility is, there would be other ways of ranking decisions also, but considering utility is one of the main parameters based on which we are trying to rank a decision, we need two things. Number one is what is the utility function, that is UW depending on the wealth W, and number two is basically what is the corresponding probability of that function UW, and based on that probability function can be either PMF or PDF, which is probability mass function or probability density function, and it will have all the properties for probability. We have discussed that in DADM 1. So, based on that we find out its expected value, and we rank them from the expected value from the highest to the lowest and take the decision. Now, as I pointed out, obviously, if the expected values are same, obviously you will try to rank them based on their variance. Variance is basically some sort of loss or negative value, and we will rank them from the minimum to the maximum and take the minimum one. These points will come up later on also as we discuss. Another point to remember is that what if we have to basically take both the expected value and the variance into consideration, how would you do that? So, in that case the ranking system would be, if we have both the maximum the expected value and the variance also, we will find out the ratio of the mean to the variance, rank that ratio from the highest to the lowest, take the one where the values is the highest. Highest means the ratio of the mean to the variance, and we take that ratio, which is basically a sort of efficiency where you are putting weights in such a way that the ranking is the numerator is basically the expected value and the variance is in the denominator. Now, what will happen if we take the inverse ratio, that means we take the ratio of the variance to the expected value. In that case, variance to the expected value would be just the reverse. In this case, we will basically rank them from the lowest to the highest and take it accordingly and rank them and take the values for which it is the lowest value. Lowest value means the ratio of the variance to the expected value. Now, there are different measures of variance. I am not digressing, but I am just mentioning that variance can be, as I mentioned in the finance concept, it can be beta. In another case, say for example, it can be the standard deviation, or it can be the, as variance is already mentioned. In many of the distributions for finance, we consider conditional value at risk, we considered expected regret, we considered value at risk. So, all these things can be considered as a sort of loss or some sort of variance, not exact variance, some sort of variance. Based on that we try to rank them, and then also we follow the same concept of trying to rank them from the lowest to the highest if it is only the variance, or try to basically rank them from the highest to the lowest if we take the ratio of the expected value to the variance, and if we take the ratio of the variance to the expected value, we rank them from the lowest to the highest. So, depending on what the ratio we do it. So, without much ado, I will continue the discussions about utility. So, let us consider an example. Consider an example where a single individual is facing the same set of outcomes. Consider an example where the individual is facing the same set of outcomes at any instant of time, but we try to analyze his or her expected value addition or utility separately based on two different utility functions. What are the utility functions? The first one and just highlight it. For first one which I have highlighted using yellow color is a linear utility function, because you see u w1, 1 in the bracket means the first utility function, it has no numeric concept, is basically the first utility function. So, that value is w plus 1. So, again w1 means the corresponding utility function's wealth. And the second utility function, let me use a different color, a lighter one, a green one. So, the second utility function is again is a quadratic one, that is w2. In that the bracket, the 2 is basically the nomenclature to define the wealth. Obviously, the wealth values w1 and w2 can be same, but is a nomenclature to define. So, that is w square plus w, and the utility function is denoted by u w2, just to differentiate that. So, now concentrate on the table which is shown. So, the outcomes are given in the first column. So, again if you remember, the outcomes are corresponding to the values. Now, the outcomes concept and what we did in the example for the football match or for the machines A and B, those outcomes are intrinsically different. In that case, outcomes were given per se as the utility or the value which was coming out from taking the decision. But here in this case, the outcomes are the corresponding values of w, based on which we will try to find out the utility. So, even if the nomenclature of the column is same outcome, but they have different connotations. So, just I wanted to mention that. So, be careful about that. So, the outcomes are given as 15, 20, 25, 10, 5 and 25. Again remember, these values of 25 can basically are two different instances where the wealth is being invested, and you will have different utilities based on that. So, the wealths are given, these outcomes which I'll denote later on also, they can have a third meaning. So, it is like this. In the first case, the outcomes, it will be specified depending on how the problem is. The outcomes are the corresponding values of utility. So, it can be, I will just write it down. So, outcomes if we mean, we can mean u w also. So, obviously the final value. So, wealth is not given, utility function is also not given, only the functional value of utility is given. So, that is the outcome. So, that is case 1. In case 2, depending on the problem, the outcome can also mean w, that is the wealth. Generally, we will denote it by wealth or amount of money, but it can be denoted by outcome also depending on the problem. In the third instance, it would depend basically denote the number of such happenings or number of the experiment or numbers when you basically play a game, take a decision. Those values would basically be denoted by NW, such that given NW for all the which are basically the outcomes, we can find out the corresponding relative frequency, we can find out the corresponding probability. That means, we are able to find out the probability mass function or the probability density function. So, outcomes would have different connotations accordingly. So, coming back to this problem. So, this point 1, 2, 3 which I have noted down on this slide would come up again, and it will become very apparent as we solve the problem. So, the wealth W1 basically gives you the wealth which is being invested by that person corresponding to the fact that utility function 1 is valid. So, they are 1.5, 2, 2.5, 3, 0.5 and 5, and the corresponding values I will just check it. So, there is we have to check this value, just wait, when we do the calculation we will check it, and the corresponding utilities would be given by, oh this is fine. So, you will basically have 1.5 plus 1 which is 2.5, 2 plus 1 is 3, 2.5 plus 1 is 3.5, 3 plus 1 is 4, 0.5 plus 1 is 1.5, 5 plus 1 is 6. So, this is right. So, let me erase it. So, the utility functions u w1 are given, which is the third column where I am hovering my pointer. Now, obviously, there would be corresponding probabilities. So, when you find out the expected value of the utility, you remember we multiplied by two terms. One was utility, which is already here, and one was NW by summation of NW, which this value has to be found out corresponding to the fact that the fourth column PW1 would basically give you the probability, because that is the relative frequency. So, what we need to do later on, I will just put another color combination, we have to basically sum it up. So, our main interest is, I am using different colors to in order to make you understand. So, the red color is basically the utility corresponding to the W value, which is given in the second column. The second color, which is the green, is basically the relative frequency, which is given in the fourth column, and the summation we have to find out, based on which we will basically rank them. Now, from where does the relative frequency or the probability comes? So, these outcomes which are given, the outcomes which are given are utilized to find out the relative frequency. So, they are basically the number of outcomes which are favorable. So, 15 divided by the total sum, or 20 divided by total sum, or 25 divided by total sum, all those values are given in the fourth column. So, those corresponding values are, because the total sum is 100, is the ratios are 0.15, 0.20, 0.25, 0.10, 0.05 and 0.25. So, once you do this, so this is the first set of calculation. So, you will basically be multiplying utility with the probability. So, once you multiply, the value comes out to be 3.825, it is given. Now, let us go to the second utility function. So, with this I will erase all the colors and then proceed. So, it will be, so we use summation as rather than erasing, I will just point it out again. So, it is not difficult for you. So, let me use the color red. So, these utilities would basically come from here. The wells, again remember, the wells have been purposefully kept at the same values, that is W2 and W1 are same, in order to make an ease of comparison. The green values, which is the ratio or the relative frequency, is given by this, and the summation obviously remain the same, and these outcomes again I purposefully again taking them to be same. So, the ratios also, that is the last column probabilities 0.15, 0.2, 0.25, 0.1, 0.05, 0.25 are the same. So, again these are calculated using this. So, I have just circled it twice in order to make you understand that they are being used in both the calculations of for UW1 and UW2. And finally, when we multiply, I will just note it down. So, we multiply these values, they are utilized, and the value comes up to 12.69. So, the utility, expected utility based on utility function 2, which is the quadratic one, comes out to be about 13. I am just finding out the integer values, and the expected value of the utility based on the first utility function, which is the linear one, comes out to be 4. So, we can have a different decision depending on the utility function which is there. That means, a person can take different decisions as the utility function changes. So, obviously, you may ask that we could have different wealths also. So, the reason for taking the wealth, I am again repeating it, it is basically for ease of comparison, and the outcomes are also same for ease of comparison, but in reality the wealths can be different, the outcomes can be different. Here the outcomes, again I am mentioning, are the number of outcomes which are favorable for any decision. Now, we have two different utility functions used one at a time for two different decisions being made, and they are like this. Again, I will highlight the first one was yellow. So, I will use the same coloring scheme. So, the first utility u w1 is linear w1 minus 5, and the second utility function I will highlight using red is a not a quadratic one, but it is non-linear because w to the power 1.25. And again the outcomes which are given are the numbers which support a decision. Again I have taken those numbers in such a way such that later on we can differentiate the decisions based on utility 1 and utility 2, you will see it very soon. For ease of comparison, I take the wells as same, which is the second column. The wells values are 4, where I am just pointing out 4, 5, 6, 7, 8, 9 just for ease, and the utilities are taken correspondingly. So, if you consider utility 1, so for wealth of 4 it will be 4 minus 5, which is minus 1. If you remember, we have taken or considered that if it is negative we will consider as 0. So, 4 minus 5 is minus 1, it will be taken as 0. 5 minus, which is now we are going to the second row. So, for the second column. So, 5 minus 5 is 0, it is 0, 6 minus 5 is 1, which is 1, 7 minus 5 it is 2, it is 2, 8 minus 5 it is 3, it is 3, 9 minus 5 it is 4, it is 4. So, the utilities based on utility function 1 are given in the third column. Now, if you consider, I will come to the decisions later, let me first consider the utility values. So, if I consider utility function 2, which is highlighted by red, the values are given in the fourth column, and how would you find out? You will basically find out using the wealth, which would be, if I consider the first row, it will be 2 into W2, which is 2 into 4 minus 4 to the power 1.25, value comes out to be 2.34. Second value would be 2 into 5 minus 5 to the power 1.25 comes out to be 2.52. Third value comes out to be 2 into 6 minus 6 to the power 1.25 comes out to be 2.6. The fourth one would be 2 into 7 minus 7 to the power 1.25 comes out to be 2.61. The second last one comes out to be 2 into 8 minus 8 to the power 1.25 comes out to be 2.54, and the last value comes out to be 2 into 9 minus 9 to the power 1.25 comes out to be 2.41. So, the utilities for the second utility function, utility values for the second utility functions are given in the column 4. So, I will just highlight them with using different columns colors. So, this is the utility for the first one. Oh, I should basically use the same color, it will be easy, my mistake, sorry. So, this is for the first one, this is for the second one. Now, if you remember, I mentioned that I would not be considering the decisions immediately. The reason was not this, it will become clear to you. Concentrate on the last two columns. So, it gives decision A, there are some yes, no, it continues both for the last but one column and the last column. Now, it means that if decision A is yes, it means that if you take that value based on the utility, you get a positive outcome, and if it is no, it means that even if you are investing some money, the outcome is basically 0, or taking a decision, the outcome is 0. Obviously, in that case, when you multiply the corresponding probabilities with the utility function, actually the total value of that multiplication values, that is utility into the corresponding probabilities, would be 0. It means that for that particular decision, the corresponding probability mass function would be 0, because these are mass functions only, they are not continuous distribution functions. So, if you take decision A, if you see the column second last one, it is yes, no, no, yes, yes, no, which means for outcome 8 it is possible under A, outcome 3 and 4 it is not possible, outcome 6 and 9 is possible under A, and outcome 5 is not possible under A. Now, corresponding if we move to decision B, again you will see it is given as no, yes, yes, no, no, yes. The corresponding logic would be for outcome 8, 6 and 9, the decision under B is not possible, while outcome 3, 4 and 5 under decision B is possible. Now, within information we will try to find out the expected value. How we do that? Let us come one by one. So, now there would technically be 4 combinations. Why 4? For utility 1, I will consider both decision A and B at one time. Then again for utility function 2, I will consider decision A and B another time. So, they would be 2 into 2, 4 decisions. So, let me come to this. Consider utility 1. So, utility 1 we are using yellow color. So, I will highlight it. And let me utilize the utility values. Let me use a different color for utility decision A and decision B. So, one can be green. So, this is green. So, I will highlight this. I will come to a different color for decision B. Now, if you look, it was yes for 8. So, obviously, the corresponding utility for that particular decision would be, what is the utility was 0, it was here, I will not highlight it, I will just mark it, it is 0 multiplied by the corresponding value which you have. So, how many of the total outcomes are corresponding to 8? It will be 8 which comes in the numerator divided by, out of the total one of 8, 3, 4, 6, 9, 5, only 8, 6, 9 are favoring decision A. So, obviously, the corresponding probability will be 8 which favors that particular first outcome divided by the total number of outcomes which is 8 plus 6 plus 9. Similarly, if I go to the second decision which is favorable under decision A, so 3 and 4 are not possible. So, we go to basically 6. So, it will be 6 divided by 8 plus 6 plus 9. Similarly, if I go to the second last one which is 9, 9 is favorable. So, obviously, the corresponding probability would be 9 divided by 8 plus 6 plus 9. And obviously, for both these probabilities we will multiply by the corresponding utility values which will be 2 and 3, which you can find out from the value which is there in the third column. So, the value which comes out for the total expected value is 1.69, which is here. I am just hovering my pointer over 1.69. Now, when I go to decision B, let me use a different color. This is only for utility 1. So, the corresponding utilities we know as is 0, 1 and 4. Why it is 0 and 4? Because there are 3 yes and 3 no's. Yeses are for 3, 4 and 5. So, obviously, the corresponding values would be 3 divided by 3 plus 4 plus 5, next would be 4 divided by 3 plus 4 plus 5, and the last one would be 5 divided by 3 plus 4 plus 5. And what are the corresponding utilities? Utilities are, if you see the corresponding column value which is basically now the fourth one, they would be okay, sorry, because we are considering the utility 1. So, we would not go into the utility 2 fourth column, we still are in the third column. The third column values corresponding to the utility for where it is yes, 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 for the last row are values 0, 1 and 4. So, when you multiply the corresponding probability into the utility, sum them up, the value comes out to be 2, which I am hovering my pointer. So, if you rank them under this utility function 1, decision B would be higher placed on a higher level than A. Now, let us change the scenario. We come into the utility function 2. So, the values I will just utilize the colors. So, it is, so this is the decision A, decision B. I already colored it. So, it is easy for me to explain. So, if I go to utility 2 corresponding to the decisions A and B, the corresponding values are, if you see yes, yes, yes and no, no, no for the corresponding last column and the second last column. the n you multiply the values would be 2.34 would be for the fourth column. If you see this value multiplied by the value. So, it is basically for decision A it is yes. So, it will be 2.34 into 8 divided by 8 plus 6 plus 9. Then the next one would be 2.61 here into 6 divided by 8 plus 6 plus 9, and the last one would basically be 2.54 into 9 divided by 8 plus 6 plus 9. The value comes out to be, if you multiply the probability and the utility values and sum them up, comes out to be 2.5 approx. Let us go to decision B. So, again the utilities you will find out from the fourth column. So, these values are 2.52 because it is yes, the next value is 2.6 which is yes, and the last value which is yes, which is 2.541, and the corresponding probabilities are. So, if you consider only the yes, 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 the probabilities are, let me repeat it for all the 3 values consecutively, they would be 3 divided by 3 plus 4 plus 5, then 4 divided by 3 plus 4 plus 5, and 5 divided by 3 plus 4 plus 5. The total value if you find out by multiplying the probability into the utility comes out to be about 2.5. So, in this case under utility 2 you are indecisive between decision A and decision B. I took a little bit longer time in trying to explain, but it was the main crux of the matter was that depending on the utility, depending on the decisions, depending on the probability, depending on the outcome, you can have different ranking systems, but and these values of probability, utilities, outcomes would differ depending on what the example is being stated as. So, let us consider a very simple example. A venture capitalist is considering 2 possibilities of an investment. The first alternative is buying government treasury bills which cost rupees 6 lakhs, while the second alternative has 3 possible outcomes, the cost of which are 10 lakhs, 5 lakhs and 1 lakhs. Corresponding probabilities are 20%, 40%, 40%. So, the sum of the probability is 1 and it is a probability mass function. Now, let us consider power utility function which is w to the power half, and then let us find out what are the decision based on the government securities and the decisions which have 3 outcomes correspondingly. So, the corresponding values are like this. So, if you consider the first one, so obviously the utility would be, so if we consider, let me, so the first one is 6 and 6 lakhs, I will not use the zeros, 6 lakhs, and the value and the probabilities is 1 because there is only one decision. So, the utility let me use as U1 suffix 1 in order to make you understand. So, it will be because the wealth is 6 lakhs and the utility is power function. So, it will be 6 into, let me use the zeros in order to make you understand and let us make no confusion. So, it will be square root of that multiplied by 1, this is the probability. So, the expected value, let me write the expected value of U1 is this, while the expected value of U2, I am using a different color. So, what are there are 3 outcomes. So, it will be square root of 10 into 10 to the power 5 because it is 10 lakhs into what is the probabilities? Probability is 0.2 plus 5 into 10 to the power 5 into 0.4 plus, let me write the last value here, this, or rather than cluttering it, the last value would be square root of, I will try to overcome this in the next class. So, it will be 1 into 10 to the power 5 into 0.4, find out this expected value, find out this expected value. So, this green one comes out to be 609, while the government one comes out to be 776. So, based on that you will obviously you take the government one because the utility is much more. So, this is a simple example, we will make it a little bit more complicated as we proceed, but we will try to utilize the concepts of utility in trying to basically go into the later part of the multi criteria decision making and the multi attribute utility theory. Thank you very much for your attention and have a nice day. Thank you.